So, welcome back. Today we'll discuss about another machine learning project, agriculture crop selection using machine learning with random forest algorithm. So, first of all, we should know what is random forest. It is a machine learning algorithm, yes, of course, that uses many decision trees to make better predictions. See here, I have a picture for you. In fact, two pictures. So here I have not one tree, many trees are there. Here also, many trees. Each tree will use random set of data. From the data set, they choose random data, random rows, then they will choose, each tree will choose random features or columns, not the same columns or features are chosen by every tree. They choose different features, different columns, and each of these tree will make predictions, and we will predict the output. For if we are using classification, we'll choose the final result by voting, and if you're using regression, the final result will be based on the average predictions of each tree. That's what uh, random forest algorithm, and by using this way it improves the accuracy and reduce the errors in prediction. Okay, so how it works: create many decision tree using a random part of data, right? Then pick random features. The features also pick randomly, not every tree will choose a particular feature. No, they choose different columns, different features, so that it can be different. It look different from others, right? Each tree will be different. Now each tree makes a prediction based on what it learned. Then combine these predictions. So for classification, the final answer is the one that most of the trees agree, and via majority voting. For regression, the final answer is average of all the predictions of the trees. By using this way, we can avoid overfitting and makes the overall prediction more accurate and trusty. Okay, that's the theory part for this one. So I am going to do this algorithm for predicting the best crop for the given features. I have my data set download from Kaggle. This is my data set. I have temperature, humidity, pH value, rainfall, soil moisture. These are the features, columns. Based on these columns, the label will be like muskmelon is best for these situations. And another one, see, this values for temperature, humidity, soil moisture, all these values given, this one means the crop should be more beans, like that. Okay, so why we use this is, usually when a farmer is going to decide which crop is best for his particular situation conditions. Okay, so how he will decide? So previous experience, but here I have a scientific explanation which crop is best for the given conditions. For that, I can use this project, okay, using random forest algorithm. I'll open that project here in the same Google Colab. I already uploaded the which one CSV file. How I upload? I just click this button, okay. Then I want to go and choose the which one Excel file, open. Then you want to press OK. It will come over here. Okay. If you want, I can try one more time. See here, this one. I'll go to crop, open. Okay. Once it is done, it's already there. Now I will take this copy path. Where is the statement? So here I am reading that which one data set I put here. Okay. Now, first thing is you want to import the packages, right? So you know pandas, numpy. We already discussed in the last which one video. Numerical Python, pandas for that operations for array, all those things. Okay. Then train, test, split. This is the function used for dividing data into training data, test data. It is from sklearn model selection package. Then we have random forest classifier. So to choose a random forest, no, we need to call this package. Then label encoder will discuss later. Label encoder means convert the label into numbers, like muskmelon, whatever labels are there, the text should be converted to numbers. That number conversion done by label encoder is taken from sklearn.preprocessing. accuracy score and classification report. For all those things, we call this particular which one package. Then matplotlib, and these are used for projecting or displaying the histogram plots like this. We discussed the last which one project. For plotting this type of histogram plots, we need to import these particular packages. SMTP-lib, I told you it's for email communication. We're not using till now. Okay, job-lib I'm not using. I'm using pickle. Now, first thing after this one, first you have to run this one. Now we are going to load the data set. For that, I want to call the object of panda dot read underscore CSV. They will read the CSV file, the data set they will read, and they will store into variable data. If you want to print the data, just put here print of data. Sorry, all small letter, print of data. Just try what is printing. It will print the data set. See 2200 rows, 6 columns more. Okay, available. I want to print the first few rows, only 5 rows. Like just go for print of head data, the whatever the array name you declare dot head. Okay, then if you want to put the last 5 rows, data dot tail of. Okay, I'm not using. Now what are these encode categorical label? These statements will convert the labels muskmelon whatever is the label part no into numbers. Okay, so for that what I need, first thing you want to declare an instance of label encoder. I just created an instance of label encoder. Then I want to call the function fit transform that will convert the label into numbers. Now after doing this statement, what I will do, I will print the data. When I print the data, what happens? See here. This label earlier it was muskmelon something, now it is converted to numbers 15. So muskmelon means 50 like that. Okay. Then I am going to divide the data into two sets x and y. X contains all the features, that means temperature, humidity, pH, rainfall, soil moisture. Y contains all the labels, that means this 15, 20 and all. So X contains all the features, Y contains all the targets or the labels. So here see the statement X equal to data draw dot drop of column equal to label. That means I am going to drop the label column from data and I will store in X. So X will contain only 1, 2, 3, 4, 5 columns. Okay, then Y equal to data of label. You want to print it? Yes, I will print now for you. Okay, print of X, then print of Y. Let's try. X only temperature, humidity, pH, rainfall, soil moisture. Y is only 15, that numbers. Done. Now split the data into training data, testing data. As we already discussed in the previous video, we have to train the model and we have to test it. For that I need to divide the data into training and testing data. Out of this 2199, okay, that much rows, 2200 rows, right? I will take convert into x and y. So text size is 0.2 means 20% of the total data will be used for testing, 80% for training. Okay, so x underscore train means the features in training data set. X underscore test means the labels in testing data set. Clear what I'm telling? Sorry, X underscore train means features in training data set and X underscore test means features in testing data set. Okay, Y means label, that muskmelon or numbers. Okay, so Y underscore train means in the training data set how many the details about the labels. Y underscore test means the labels or these numbers in testing data set. How it is done? We are dividing using this function train underscore test underscore split x comma y. 20% you want to choose for testing, 80% for training data set. Random state 42 means this has to be continued. Okay, same data, training data, testing data, that particular division should be uniform. That's why we use the random number. Okay, we have to replace the same. It's not like every time training data and testing data will be changing. Okay, and we want to run this one. After that, we are going to train the random forest model by using ran this one fit model.fit of x underscore train y underscore train. Before that, we'll run this one. See, first statement, model equal to random forest classifier bracket n estimator 100 and random state 42. This one means, as I told you, in the random forest we'll generate multiple trees. So how many trees will generate depends upon the number you mentioned here. The 100 is the n estimator, means I will generate 100 trees. Random state 42 means this is a number which we use, okay, for like we need to reproduce the same training and testing data, that 100 trees every time reproduce the same thing, we have to use a number here. Okay, then model dot fit of x train y train means I am going to train the random forest model by using the training data, like x underscore train means the training data set with features, y underscore train with means training data set with labels. So we are giving these features and labels from training data and train the model by using fit function. Now the model gets idea. These are the features, these are the labels. So they get an idea. Okay. Then I am going to predict on test data. What I'm going to do is I give x underscore test. That means the features in testing data set. I'll predict, and what I'm going to get is y underscore pred. This is a variable. What it has is the label they predicted. So out of this x underscore test, whatever values we have in testing data set, any that features, I will predict the value of which one labels, and I store in y underscore predict. When I print that one, I could see different labels. Each will be musmal and whatever. Okay, the numbers. Now you want to evaluate the accuracy of your model. For that, we need to use accuracy underscore score, y underscore test, y underscore pred. This is comparing accuracy. Accuracy is defined or determined using y underscore test means the testing data set with containing the labels. Y underscore pred means the label which we have got by using predict function with x underscore test. That means the features in testing data set. We'll use these two and predict the accuracy, and we get the accuracy printed as 95.68. One more thing we use in this particular program is classification report. There, in not just we are printing the accuracy, we can print the precision, recall, FN score, and all those things. Okay, what is precision recall? You can just check here. So precision is the ratio of true positives to total number of predicted positives. Okay, so how many total predicted positives? So true positive divided by total number of predicted positives. That is precision. That will give the accuracy of the positive predictions made by the model. Okay, and what is recall? Ratio of true positive to total number of actual positives. So it is the ability to correctly identify positive samples. This is not that much compulsory. You can just stop with accuracy. If you want to print more details about precision, recall, F1 score support, then you can try this. Okay, what about F1 score? Mr. What is F1 score? This is a mean value of precision and recall. Okay, see here, this is the harmonic mean of precision and recall of classification model. It indicates the reliability, how reliable is that particular model. Done. After that, what I will do, I will use a function to predict the crop. So function name is predict underscore crop. Okay, I'll just do this one. Inside that we have features. What are these features? The features will be temperature, humidity, pH, rainfall, soil moisture. Okay, here I will give the values. So in manually I will type temperature, humidity, pH. So here we, as we discussed, no, manually I will add temperature, humidity, pH, rainfall, soil moisture things. as a testing data set. Then I want to predict what will be the crop for this particular features. So for that I use predict underscore crop function. I will pass all these values. We have temperature, humidity, temp, humidity, pH, rainfall, soil moisture. Temperature I put 18.51, like that I put. Okay. Then when I call this one, this will go back here. Here we have definition for predict underscore crop function. First thing is convert the raw data into two-dimensional array by using this np.array features and reshape function. Now the features will be ready in array format. Now I want to predict the feature, like what will be the correct crop. Here I have converted that into numbers, right? Now the label is in numbers, so that numbers you will get in prediction variable. From that numbers I want to get back the label name. The user cannot identify, okay, 15 means muskmelon, or 15 means 20 means which one, blueberry something, they cannot identify. So what I need to convert the number into label. For that I use the function inverse underscore transform. This is the function which convert the number into label so that the user can identify. Or the, see here I have already mentioned here, uh, label underscore encoded inverse transform means it is a function which revert or convert the encoded labels back to original value. Okay, whatever is the no, which one we converted that into numbers, right? In the beginning, that numbers will be returned back to label the text value by using this function. Now see, I'll go back to this one. Now first I will use this, which one, function. Now function is done. Now I have entering these values. Now then I'm going to print the recommended crop. So when I call this function, the recommended crop, whatever is the actual crop, they will this function will return the value to this variable. Now I am going to print that variable name, variable value, so that I can get the correct crop or crop for this particular features. So I'll just print this one. Now I get maize is the correct crop for these values: temperature 18.518, humidity 55.1.5, pH 6.64, like this. Okay. Now if you want to save this model, so that you can call this model in Raspberry Pi with real sensors, actual sensors for reading temperature, humidity, pH, and rainfall and soil moisture. We can import the model using pickle. So import pickle, then with open, what is the name of that model name you want to mention? So just give crop, I put crop 4, so I'll put like a crop 6 dot pkl. Okay, writing mode. Then I want to dump that which one, model. I'll run this one. Few seconds we get the model here. Okay, now this is the model which you can call from anywhere. Raspberry Pi, go to Raspberry Pi, there you can call this model. Then you can read the, instead of giving the actual values here, no, you can read the values from the sensors directly. Then you can send that values into this model. Okay, now to generate the histogram plot like this, we can call the this one function, histogram function. Okay, temp, I want to declare the numerical columns. Okay, what are the columns we need? Temperature, humidity, pH, rainfall, soil moisture. Then size is fixed size, plot dot figure of fixed size 15 10 means 15 row 10 column, the width 15 width 10 height. Okay, sorry. Then I'm going to call a for loop for these variables one by one. Then plot 3 3 I means 3 row 3 column, so we don't have a value here, feature here, so that's why this is empty. After that we want to plot this one. KDE true means we need a smooth transition in that histogram curve. Okay, then we have to put a title here, as we discussed in the last video. Title for each histogram plot. Okay, temperature, humidity, this one. Then tight layout, it should be inside that your picture, the plot should be inside that particular plot, and show, display this on the screen. This is how you draw the histogram for which one, your features in. So after that program, right, We got the histogram output. So the continuation of this one is, after making that model, I am going to download this model. Like I imported the model, right? By using pickle, I download the model. Now I will call this model in my Raspberry Pi, and I have some sensors. I'll show you the topology. This will be my topology. So here, this is soil sensor, soil moisture sensor. Okay. So see here what we have in our program: soil moisture sensor, rainfall, pH, humidity, temperature. Okay, so how much moisture is in the soil? So how we find out that? We want to add the soil moisture sensor in a pot where we have soil. Okay, it will a bit moisture will be there. We have to get that moisture from that soil. Then we have rain sensor. Then we have temperature, humidity, and we have pH sensor also. I'm just waiting for pH sensor. Okay, after connecting all these sensors into this Raspberry Pi Group Pi board, we will write the program, and I will call the model which I already got. Now this model crop 6, I will download the model into my computer, local PC. Okay, local drive. Then I will call the model in my Python program in Raspberry Pi. After that, I will read these values. So see here, temperature 28, humidity, soil moisture, rain, whatever values I read from the sensors, I will upload to cloud, as well as I will send these values to the function which I have. Which one? Predict crop function. I will use this function in the model, and I will send these values. I will not manually do. I will read from the sensor. See, from these sensors I will get the actual value, and these values I already printed here. This one I will send to the models predict crop function, and from here, from this particular model, I will get the output in the Raspberry Pi screen. I'll get the output in Raspberry Pi console screen, and then it will tell you what type of crop is best for the current temperature, humidity, soil moisture, everything. This is what my extended part of my project. Not just creating model is my motto. My motto is to connect this model with the real world, yani the actual sensors. They will get the value. These sensor values sent to the prediction function model. Then the model will predict me which crop is best. Then I will tell this information, pass information to the farmers. Okay, that's how technology is getting useful, becoming more useful for the farmers. Clear? See you in the next video. Bye.